We are AEGIS. We have built a missile defense simulation platform, and we are so excited to share that with you guys today. So, for introductions, my name is Spencer Hoff. I was the AI database lead for the project. My experience includes working with APIs, AI, databases, and backend in general.
Hi, my name is Matthew Duffin, and I was a full stack developer working on AEGIS. I have experience in C# and full stack development from my time working at Swire Coca-Cola, and I also built out our wind data reporting feature.
Hi, I'm Luis Sanchez. I work with 3D computer graphics in Unity. I mainly worked on the Unity UI as well as the 2D and 3D visuals.
And my name is David Nixon, and I served as the principal physics engineer designer for AEGIS. And I'm dedicated to building the innovative high-fidelity simulation code that drives real-world impact. So, along those lines, let's get into the question of why AEGIS. AEGIS exists because missile threats are evolving faster than the tools we use to understand them. Around the world, long-range and hypersonic systems are rapidly increasing, and every launch now has the potential to affect global security, not just a single region. One successful strike can have devastating consequences for national security, damaging infrastructure, weakening deterrence, and putting civilian populations at risk, which in turn undermines global stability. Yet many current simulation tools are fragmented, hard to learn, and not designed with modern workflows in mind. So AEGIS targets that gap. A simple, unified platform that lets researchers, Department of Defense analysts, and decision makers model what-if missile scenarios, test defensive options, and build more resilient strategies before a real crisis actually occurs. So with that, let's move on to our demo.
All right, welcome to the AEGIS application. So here you can see we have a nice rendering of the globe here. Let's go ahead and pretend I'm a Department of Defense employee, and my manager has asked me to simulate an assault from this launch site in Russia attacking New York City. So AEGIS allows us to simulate that. I can go ahead and right click on this area here and create a missile. Let's go ahead and call it Minuteman V1. We have a bunch of different parameters here for creating missiles. Let's go ahead and launch it from the Russian launch site. You are also able to create custom launch sites, but for this case we'll use some of our preloaded ones. We have missile templates here that you can use for the base stats of the missile. We'll go ahead and use a Minuteman 3. This makes modeling simulations and missiles very simple and easy. You can use a pre-existing missile template to improve your speed and accuracy of getting these simulations up and running. Let's also increase the blast radius here, and then we can go ahead and click play on our sim and watch our missile fly out of the Russian cosmodrome. We have a bunch of really cool features here, including some overlays that let you see the missile's distance as you click on it. We're also able to pause our simulation, view things here, click play, fast forward. We're also able to rewind should we choose to, and we can go ahead and watch our missile as it comes into impact. So let's fast forward that up a little bit here, and we can see as it gets ready to explode outside of New York City, causing a nice little explosion there, encapsulating the city. So obviously we want to be able to simulate what defensive strategies are available to us to be able to prevent this. You just provide several different strategies here. What I'll do for this particular demo is I'll create a defensive ship, but you can also create defense silos, as well as integrate some of their triggering mechanisms into satellites. So you can see here we have different guidance modes. We're doing radar proximity, where if it reaches a certain range within the interception site, the interceptor will fire. But like I said, you can integrate that with satellites as well. Let's go ahead and call this ship the US Peacekeeper. And then we have interceptor template missiles here. I'm going to go ahead and use the THAAD for our case here. And we also have a nice trigger range. I'm going to go ahead and make this 750 kilometers, and then I can go ahead and submit here. So let's suppose we want to see our coverage here. We can click our defense proximity, and you can see we have quite a wide range here available to us. So let's go ahead and watch how the simulation plays out. So we can see our missile firing. Let's go ahead and turn off. We also have some nice overlays here if we just want to see our missile. And we can go ahead and watch it as it comes in. So let's go ahead and fast forward here. We can see our interceptor fired and caught the missile, which is great. But let's suppose that the French Guinea also decides they want to take out some of the United States' infrastructure in this scenario. We have the Orlando International Airport, and that's the target. So I can go ahead and click here, create our missile. We'll call it the Minuteman V2, and we'll go ahead and launch it from this location. Let's go ahead and increase our blast radius. Let's do 75. Let's move our speed up to, let's go 7. And then we can go ahead and submit that here. So now when we click play, this location is undefended. And then we can go ahead and turn back on our trails and pathing here to make that a little bit easier to see. And we can go ahead and fast forward this along and see our airport get hit as well. In AEGIS, we have a nice, robust reporting tab, so we can kind of see what happened in this simulation. About 156,000 people died. We had 50% defense effectiveness and intercepted 1 missile. $4.5 billion worth of damage done. So we kind of are able to calculate how many missiles we intercepted. Obviously, we only got 1 of them, resulting in a 50% defense effectiveness. But let's go ahead and improve our scenario for our higher up. We can go ahead and create a defense silo called the U.S. Defender. This is a land defense mechanism. And we'll keep it radar in proximity. And we'll give it a trigger range of 7. Let's go 1,000 on this one. So let's see what our area of coverage is now. As you can see, we got a larger defense coverage from this proximity here. And then we'll click play and see if we're able to intercept both missiles. And it does look like it does hit here with indicated by this green line. Let's go ahead and see them come in a little bit closer. And we can watch this happen in real time, preventing destruction of the airport. And then if we jump into our reporting tab, we can see we've intercepted 2 missiles and we have 100% defense effectiveness. So I'm able to save this scenario should I choose and export it to my boss. Let's go ahead and show that. Let's drop this here. Go ahead and save it as the East Coast attack. And then I'm able to share the AEGIS file to my boss. He's then able to load in the simulation with our load functionality. Let's go ahead and show that off here. We can jump into this file here, which I wanted to load in, which is a preload simulation with a lot of other things going on. So once this clicks play, you'll see a bunch of different things happening here. You can see several missiles firing, a bunch of interceptions happening, and things along that nature. But let's keep ramping up the ante. We can load in a larger simulation to kind of show the maximum effectiveness of AEGIS to simulate large-scale battles. So if I click play here, this one's going to take a little bit more time to load as we are loading in a huge number of missiles. It's around 50 missiles that are being loaded in, as well as satellites to kind of show off some of the satellite visualization of what that looks like. You can see we have a ton of things happening on our screen at once, showcasing AEGIS's full potential. And that's our demo. We have a lot of other features we can't wait to show off on demo day, including dynamic wind pattern data that has an overlay, power overlay, as well as our AI chatbot. So we hope to see you there.
Awesome. We just want to share about what users we cater this project towards. There's lots of different types. So we have researchers, students, Department of Defense contributors, policymakers, and non-technical users. We built this project in mind of all of these different user types.
For AEGIS, we're using C# as our main language for building the core logic and functionality. We're using Unity to build our project, to build the front-end UI, as well as the 3D visuals. And we're also using SQLite for loading and saving our databases.
Yeah. So going over this graphic right in the middle of the screen very briefly, to build AEGIS in a way that's reliable and adaptable for our users, we're following the agile software engineering process. This has things such as the sprint planning, sprint backlog, and then as well as pulling all that into the development and testing process. Then daily stand-ups keep the team aligned, and any roadblocks, they pop up on our radar. At the end of each sprint, we deliver a potential deliverable and run a sprint retrospective to improve our process. This is in the form of our stand-ups. This cycle lets us iterate quickly and be able to deliver a solid product at the end of each week. So with that, that is going to conclude our presentation. So we thank you for watching, and we hope you liked it.